Verse, feel like the universe is this giant, complicated puzzle, and you're just missing the instruction manual. What if I told you that one of the greatest minds of our time wrote a guide, not for astrophysicists, but for everyone? Today, we're diving into a book that changed the world's view on the cosmos, Stephen Hawking's A Brief History of Time. So, who was Stephen Hawking? Imagine a man whose body was confined to a wheelchair, who could only speak through a computer, yet whose mind roamed the farthest reaches of space and time. That was Hawking, a brilliant theoretical physicist, cosmologist, and author, who, despite his immense physical challenges from ALS, possessed an even more immense curiosity and a wicked sense of humor. He didn't just want to understand the universe, he wanted all of us to understand it too. And that's where A Brief History of Time comes in. Published in 1988, this book wasn't written for scientists and lab coats. It was written for you, for me, for anyone who's ever looked up at the night sky and wondered, what's really out there? How did it all begin? And where is it all going? It became an instant global phenomenon, selling millions of copies and staying on bestseller lists for years. Why? Because it took the most mind-bending ideas in physics and made them accessible. Let's start at the beginning, literally, the Big Bang. Before Hawking, many people imagined the universe as static and eternal. But Hawking helps us visualize a different reality. He paints a picture of the entire universe, all the stars, galaxies, everything you can and can't see, compressed into a point smaller than a single atom, a point of infinite density and temperature. Then, in a fraction of a second, bang, an explosion of space itself, expanding outwards, cooling down, and eventually forming the atoms, stars, and galaxies we see today. Hawking doesn't just state this as a fact. He walks us through the evidence, from the redshift of distant galaxies to the faint cosmic microwave background radiation, which is like the leftover heat from that initial explosion. It's the universe's baby picture, and it's all around us. But if the universe is expanding, what is it expanding into? This brings us to the concept of space and time. We tend to think of space as an empty stage and time as a constant, ticking clock. But Einstein, and later Hawking, showed us that's not the case. They are part of a single four-dimensional fabric called space-time. And this fabric isn't flat. It's warped and curved by mass and energy. Think of it like placing a heavy bowling ball on a trampoline. The fabric dips and curves around it. Now, if you roll a marble nearby, it doesn't travel in a straight line. It follows the curve created by the bowling ball. That's gravity. It's not some mysterious force pulling things together. It's just objects following the curvature of space-time. This is Einstein's theory of general relativity, and Hawking is our master tour guide through its strange and wonderful implications. One of the most famous consequences of warped space-time is the black hole, and this is where Hawking really made his mark. A black hole is what's left when a massive star collapses under its own gravity, creating a region of space-time so warped that nothing, not even light, can escape. It's the ultimate cosmic trapdoor. The edge of this region is called the event horizon. Cross it, and there's no turning back. For a long time, scientists thought that anything falling into a black hole was lost forever. Information, matter, gone. But Hawking came along and said, not so fast. He combined the laws of the very big general relativity with the laws of the very small quantum mechanics. This was a revolutionary step. And what did he find? He predicted that black holes aren't completely black. Due to quantum effects near the event horizon, they should glow faintly, emitting a tiny stream of particles. We now call this Hawking radiation. This means that over immense, almost unimaginable periods of time, black holes can slowly evaporate and disappear. This idea turned astrophysics on its head, suggested that information isn't necessarily lost forever, and that the boundary between quantum physics and gravity holds some of the deepest secrets of the universe. Now, let's talk about time. We all experience it moving forward. We remember the past, but not the future. Why? Hawking explores what he calls the arrows of time. There's the thermodynamic arrow, which is the direction of increasing disorder, or entropy. A cup falls and shatters, but we never see the shards fly back together to form a cup. That's entropy. Then there's the psychological arrow, our subjective feeling of time passing. And finally, the cosmological arrow, the direction in which the universe is expanding. Hawking points out that these three arrows all point in the same direction. Is this a coincidence, or is there a deeper connection? The book makes you ponder the very nature of your own experience of reality. And what about the big questions? Why is the universe the way it is? Could it have been different? These leads to discussions about the anthropic principle, the idea that the universe seems finely tuned for life to exist. If the fundamental constants of physics were even slightly different, stars wouldn't form, atoms wouldn't be stable, and we wouldn't be here to wonder about it. Is this evidence of a grand designer, or do we live in a multiverse with countless other universes, each with different laws, and we just happen to be in one that works? Score. Hawking doesn't give you the answer, but he gives you the tools to think about the question in a profound new way. Throughout a brief history of time, Hawking's goal is to find a single, elegant theory that can explain everything, a theory of everything, a theory that would unite general relativity, which describes gravity and the large-scale universe, with quantum mechanics, which describes the other three fundamental forces, and the world of the very small. Skew. He was a key player in the development of string theory, one of the leading candidates for such a theory. String theory suggests that the fundamental particles we see are not points, but tiny, vibrating strings of energy, and the different ways they vibrate give us the different particles, like notes on a guitar. It's a beautiful, complex idea that hints at an underlying unity to all of nature. What makes this book so powerful, so enduring, is not just the incredible science, it's the humanity behind it. It's Stephen Hawking's relentless curiosity and his desire to share his passion. He uses simple analogies like the trampoline for space-time, or the idea of an expanding balloon to explain the expanding universe to make these grand ideas intuitive. He acknowledges what we don't know, showing that science is a journey, not a destination. His writing is filled with a sense of wonder and a quiet optimism. The final chapter of the book is a conclusion that stays with you long after you put it down. Talking muses on the ultimate goal of science. He argues that if and when we find a complete theory of everything, it shouldn't just be for a handful of specialists. It should, in time, be understandable in its broad principles by everyone. Then, he says, we shall all philosophers, scientists, and just ordinary people be able to take part in the discussion of why it is that we and the universe exist. If we find the answer to that, it would be the ultimate triumph of human reason, for then we would know the mind of God. That powerful, humbling thought is the perfect capstone to this incredible journey. A Brief History of Time is more than just a science book. It's an invitation to look up, to be curious, and to marvel at the magnificent, mysterious, and beautiful universe we are a part of. It's a testament to the power of the human mind to overcome any obstacle and reach for the stars. So, if you've ever felt a spark of curiosity about the cosmos, I can't recommend this book enough. Might not answer every question you have, but it will give you a whole new set of amazing questions to ask. It's a journey worth taking. Thanks for joining me on this exploration of one of the most important science books ever written. If you enjoyed this video, please hit that like button, subscribe for more content, and let me know in the comments what book or big idea you'd like me to dive into next. See you in the next one.